Let us talk about what is the difference between speed and velocity. So speed is something which is supposed to be a scalar quantity. So whenever we are going to talk about any scalar quantity, we'll only talk about its magnitude.
Mm-hmm.
Say speed is defined as distance per unit time. It doesn't have any direction, so we simply say that speed is going to be distance over time.
Mm-hmm.
Now its unit, and to be precise, its SI unit. It is going to be meters per second. Whereas if we talk about velocity, it is a vector quantity and it is defined as the rate of change of displacement. Whenever we see that word rate of change, it simply means
Slope.
change in displacement per unit time. And in fact, it is equals to S2 minus S1 per unit time. Like how much displacement is changing with respect to the time.
It's just slope, right?
Also, what?
It's just slope because is that
No,
rate of change the slope or
no. It should be displacement per unit time. So whatever
oh,
position at which the particle was at initially, per unit
mhm,
time will give us velocity.
mhm. Okay.
As a vector quantity, again, the SI unit will be same, that is meters per second. But here, it must have some direction. The direction is supposed to be in same direction of displacement. This is how we should say this. Like
Mm-hmm.
for example, let us understand both of them through an example. Suppose there is a question and the question says a particle moves from point A to point B moving along a horizontal line covering 40 meters in, I would say, 4 seconds along the horizontal line. And then from B to C, a vertical path, it covers 30 meters in 3 seconds. So the question is find speed and velocity. So it's a pretty simple question. First of all, we'll figure it out what is distance, then we'll figure it out what is displacement, and then we'll divide both of them by time to get the speed as well as to get the velocity.
Mm-hmm.
So speed is something which is distance over time.
Mm-hmm.
So what is the total distance covered in this process?
Mm-hmm.
Can it 40 plus 30?
Yeah.
Whereas
And
if we talk about the time taken by the particle is going to 3 plus 4.
yeah.
Speed is something which is 70 by
This.
7 is 10 meters per second.
Mm-hmm.
Whereas talk about velocity, it is going to be
Oh, it would be
displacement.
50 over 7.
So what is going to be the displacement?
50 meters.
So I would say 50 over 7.
Yeah.
So velocity is supposed to be approximately 7.1 meters per second.
Mm-hmm.
So this is how we are finding velocity. But again, It is a vector quantity, so we also have to know the direction.
Mhm.
So if you remember in previous classes, we talked about directions of the vector, that how we are supposed to find the direction. And I mentioned to you that whenever we are going to find out the directions, we are going to find out the angle made by the given vector,
Mhm.
any of the given vectors. So in order to find out direction, we actually find angle. So here, if this is a right angle triangle, we can use tan theta, and tan theta is something which is perpendicular upon base. So we can write it is going to be 30 by 40. So
Mhm.
theta is going to be tan inverse 3 by 4.
Mhm.
You can
Mhm.
actually find out the value of this theta using calculator, or else
Mhm.
you can leave it till there also. That will also work.
Okay.
So we will say that the particle has velocity of 7.1 meters per second at tan inverse 3 by 4 degrees. So this is
Mhm.
how it will be a complete solution. This is how you're going to write the answer completely.
Okay.
So that is the basic difference between speed and velocity, and this is how we are supposed to find it out. You can always see that the magnitude of speed and velocity in most of the cases is not going to be the same, but in some cases in which particle is only traveling along a straight line, it will be same.
Mhm.
All right, let's move to the next part, which is going to be acceleration. So now acceleration. Acceleration is something which is defined as when the velocity of particle is keeps on changing with respect to the time. For example, I will define it as in this way. It is defined as rate of change of velocity per unit time. It is a vector quantity and it will be
Mhm.
equals to delta v by t. Delta v by t means change in velocity per unit time. It is a vector quantity and direction along direction of change in velocity. Just like in the previous case, when we talk about velocity, the direction is supposed to be in the direction of displacement. So here also, if we talk about acceleration, so direction of acceleration should be along the direction of change in velocity. That is the difference. If we talk about the unit, so unit is going to be, the unit of velocity, it is meters per second, and we know the unit of time. So ultimately, it is going to be meters per second square. So you can write it this way. This is going to be the unit of acceleration.
Mhm.
Now, let me give a very simple question. It will help you to understand or see that how we are supposed to actually calculate acceleration. So, a very basic question, a very simple question. Suppose a car initially traveling at 30 meters per second on a straight road. After 10 seconds, its velocity changes to 60 meters per second. So, here we can see that the velocity of the particle or the car has increased.
Mhm.
So, the driver must have accelerated, then only its velocity has increased.
Yeah.
So, in such cases, again, the question is find its acceleration. So, how we are supposed to do it? Let us see. So first of all, whenever you are doing any physics problem, make sure you write what are the things given in the question. So car was initially traveling at 30 meters per second, so we can say initial velocity is 30 meters per second.
Mm-hmm.
After 10 seconds, so basically we have time, its velocity changes to 60
60.
meters per second. So we have to find the acceleration. So acceleration is going to be change in velocity per second. So whenever we are writing change in velocity, so we will always write final minus initial velocity.
Okay.
So it is going to be 60 minus 30 over 10.
Mm.
The acceleration is coming out to be 30 meters per, 3 meters per second square.
Yeah.
Now, we also have to write the direction. Like, what is the direction? So it is given that it is traveling initially on a straight road. Sorry.
Bless you.
Yeah. So the thing is how we are supposed to write the direction. It is
Mm.
traveling on a straight road, so I can assume that initially the car was traveling like that with 30 meters per second. Later on also it was traveling at 60 meters per second on the same road in the same direction. So if you remember when we were discussing vectors in the previous classes, I explained that if you want to have to represent the direction along x-axis, we'll use I cap. So here also we'll use the same. So I can say it is 30 meters per second I cap, and finally also it is 60 meters per second I cap. So change is also taking place along the x-axis. So we will say it is going to be 3 meters per second along I cap. So this is how we are actually representing.
What does ICAP do?
Remember, I mentioned so we have three Cartesian planes, three axes. To represent the direction along x-axis, we use I cap. To represent the direction along y-axis, we'll use j cap. To represent
And
the direction along y-axis, we'll use k cap. So based
um,
upon this information only, we are representing the directions. So here acceleration is supposed to be takes place, or the change in velocity is supposed to take place along x-axis or the horizontal line. So we will say that the acceleration is supposed to be I cap.
mm. What is the Z? Like, what axis is that?
Z axis.
How is it traveling like that?
Like
Like,
what?
like when in a question would it say that it's traveling? That how would you know it's?
It would
Oh,
be given.
okay.
The question will suggest that velocity must be given in a vector form in those cases. So we will be got to know that the particle is moving simultaneously along all the three axes. So velocity will ultimately define it. If there is any question, we'll definitely talk about it. As of now, I don't think so. Any of the question will come and say that particle is traveling along z-axis. So we'll be able to figure it out. Let's do one more problem on the same concept. Here you will learn something. A very basic problem, let's say. A particle moving in vertical plane, I say. So you can assume that there's a ball and I throw the ball vertically upward with 40
Mm.
meters per second. After a few seconds, I observed the particle's velocity becomes zero. And I would say that it took around 4 seconds to do so. So the question is find acceleration about this vertical plane. So how can we do this? Tell me.
So you're saying you threw it vertically and it reached 40 meters or like at a speed of, I mean, velocity of 40 meters per second.
Yeah, just imagine you have a ball and you throw it up directly perpendicular to it and into the sky. So what happens to the ball? With whatever velocity you have thrown the ball vertically upward, after covering a certain height or after moving to the certain height, it will stop slowly, and then at certain point its velocity will becomes completely zero, and then it will fall back to the ground. This is what happens.
Mhm.
So you have to figure it out and tell me that what is going to be the acceleration during the process, and what we specifically call that acceleration to be precise. So I would say it is something we call sometimes deceleration,
Mhm.
or the question is also retardation. This is the case where change in velocity is taking in such a way that the velocity is decreasing. Whereas in the previous question, the change in velocity is taking in such a way that velocity is increasing. So both are different cases. So this question is suggesting the ball must be retarding, whereas the first question was suggesting that the car is accelerating. So again, the same process. Just try to figure it out. What is given, and
You do the
you can have
final
answer. So
velocity minus the initial
it will be,
velocity.
yeah, that is 40, and
Yeah.
time taken same is 4 seconds. So I
Yeah.
would say it's going to be V final minus V initial over time. That is going to be
Mm.
0 minus 40 by 4. Acceleration is coming out to negative 10 meters
Yeah.
per second. Now this negative sign is ultimately giving us the direction that it suggests. The negative sign suggests that,
It's deaccelerate, like,
yeah, it's
we
in
added J cap, right? Because it's moving vertically.
direction. Exactly. So how we would write it? We would say it is representing that it is in the opposite direction of velocity. So we will say that acceleration is going to be 10 meters per second, negative j cap.
Oh, so you add the negative, like if it's negative, you add it in the J cap, not before the negative, before the 10.
Exactly. So this negative sign is actually representing the direction. So we just shift this negative sign with its direction, which is actually represented by j cap, because the particle is moving along vertical plane. So it is along y-axis. So we can directly say it is going to be negative j.
Okay.
So we would say that acceleration is downwards, that is 10 meters per second
Mm-hmm.
square. This is how we are supposed to write it.
Mm.
All right. So let's move ahead. Next, we have to talk about questions of motion. So whatever physical quantities we have studied so far will use to represent the motion of the body, and they will came together in the form of equations, which will ultimately suggest us that how, or you can say it will ultimately help us to calculate the different physical quantities associated with the motion of the body. So there are three physical equations. The first is P final minus V initial is going to be acceleration times time. The
Mm-hmm.
second equation suggests that the displacement S is going to be V initial times time plus half a t square.
Mm-hmm.
Whereas we have another equation, that is third equation, which is going to be V final square minus V initial square, which is equals to twice of a times twice of acceleration times displacement.
Mm-hmm.
So what are the meaning of these symbols, we have to understand that as well. Vf is final velocity, Vi is
Initial.
initial velocity, whereas A is the acceleration and S is the displacement. Remember, we use
Mm-hmm.
S to represent displacement as well
Mm-hmm.
as
And T is time.
in some three books, it also suggests minus x naught as displacement. So
Mm-hmm.
whatever it is given in the question, you have to understand that it is displacement, whereas
Mm-hmm.
t is supposed to be the time. So this is how you are actually representing equations of motion. How can we use them? So let us do some problems. You'll automatically understand that how we would actually use them. Just look at the problem carefully, and ultimately you'll be able to understand. Suppose body travel at 5 meters per second initially has a constant acceleration of 2 meters per second square, has a constant acceleration of 2 meters per second square. So the question says find distance covered in seconds. So a very basic question. Use one of the equations to find out that what is the distance covered in 30 seconds. But before that, always make sure that you write what is given in the question. So it was initially traveling at 5 meters per second. So initial velocity is supposed to be 5 meters per second.
Mm-hmm.
Acceleration is supposed to be meters per second square. And also we have
Mm-hmm.
time, which is 30 seconds. We have to find that how much displacement is there in 30 seconds. So this is what which is given in the question. So now you have to figure it out of these three equations, which equation can I use to find out the distance?
Um,
Think
the first
and tell
one.
me.
The first one.
The first, the first one doesn't have displacement in it. The second one and the third one has displacement in it. So up from by third and second only we will be able to find out displacement. Now think again and tell me that which equation should I use to find out displacement.
The second
Look
one.
at, yeah, we have to see that what is given to us and which equation can we use. So we have to find that as we know that apart from equations of motion, from equations of motion, there are two equations of motion. Yes, first, second equation is ut plus half at square initial velocity into time plus half at square, or second we have is v final square minus v initial square is equals to 2as. Now, from these two equations, we have to figure out which equation should we use. Now look at what is given to you. We have v initial, so we have v initial in this equation. We have acceleration, we have acceleration in this equation. We have time. We have time also in this equation. So second equation is best to find out the displacement. Also,
Um,
if we use the
what?
third equation,
Yeah. Like, is that
if we
initial?
use the third, yeah, we didn't have this final velocity. We
Okay.
have this, we have this, but we didn't have the final velocity. So it will to use this equation to solve the question. First, we have to find out what is final velocity. Then only we can use the third equation. So I'll
Mm-hmm.
simply write using second equation of motion. Using second equation of motion, I would say displacement is going to be initial velocity that is 5 times time is 30 seconds plus half acceleration that is 2 into time square, that is 30 square. The displacement is coming out to be what? 600 plus 900. So in the
Mm.
period of 30 seconds only, the body was able to cover 150 meters of distance. So does it make sense?
Mm, kind of.
Okay, let's do another problem then.
I think I'm still a bit confused on like how do you know which one to use? Because in the question, like how do you know you have to find the displacement?
See, whenever particle was traveling in a straight line, let's say from point A to point B,
Mm.
in this case, just think and tell me uh, what is going to be the distance and displacement. Are they going to be the same or are they going to be the different?
Oh, they'll be the same.
Exactly. So whenever a particle is traveling from one point to another along a straight level road or along we can say horizontal line, the distance is always equals to displacement. So when distance is always equals to displacement, we can use these equations of motion to find out distance as well. But
Mm.
if particle is traveling at some other type of path, then we might not be able to use it directly. Then
Mhm.
in that case, there is a different way, there is a different method. And that is the thing which comes under non-uniform motion to be precise. We'll talk about that also. Let's do another problem, and I guess then it will be easier for you to understand. So a question says a particle starting from rest has a constant acceleration of 5 meters per second square. Question is find first part, its velocity after 5 seconds, displacement in 5 seconds. So this is the question. Now we have to figure it out that what is given to us. So whenever you see that word, a particle starting from rest, it means that initial velocity was zero. Rest means
Mm.
particle was not moving. So we can say that initial velocity is supposed to be zero. So
Mhm.
Vi is nothing but it is 0 meters per second. It has some acceleration that is 5 meters per second square. For the first
Mhm.
part, it says we have to find its velocity after 5 seconds. So the time is supposed to be 5 seconds.
Mhm.
Now, just think, tell me, we have these three questions. So which equation should I use to find out final velocity? This is first equation. This is second equation. This is third equation. So which equation should I use out of these three to find out final velocity, that is Vf?
The
Think
second one, because we're
and
not the second one because we're not given the final velocity.
again, the question is we have to find out final velocity of the body of the particle after 5 seconds. So which equation should I use to find out final velocity based upon this one information? We cannot use second equation because second equation doesn't has final velocity in it. So how may I able to find it out when it is not there in it?
But we're not given the final velocity. So how can you use it? Oh, wait, never mind. You can use the
In
first
order
one.
to find out, exactly. In order to find out displacement, we can use equation 2. But in order to find out velocity after 5 seconds, we will use equation 1 because it has everything in it. So
Mhm.
let's see. V final minus V initial is going to be 80. Now just look at what is given to you. We have initial velocity, we have
Mhm.
acceleration, we have time. So we can easily find out final velocity.
Mhm.
So we will say using first equation of motion. So V final minus initial is going to be 80. So V final is something we can write V initial plus 80. So initial velocity was supposed to be 0.
Mhm.
Acceleration is supposed to be 5. And time after which we have to find is also 5. So V
Mhm.
final is going to be 25 meters per second.
Mhm.
This is how we are, we need to find this out. Similarly, in the second part, we have to find out displacement. The displacement is going to be,
You can use the
we can
second
find out
equation.
using any equation. You can use any of these equation now. Because if you use second equation, we can use it. We have V final, we have time, we have A, we have time. Similarly, from third equation also, how we
We
got
are.
V final? We have V final. V, yeah.
Yeah.
Similarly, we have V initial, we have acceleration. So we can use any of these equations. But I will
Mhm.
use second equation of motion. So displacement is going to be V initially supposed to be 0. 0 times C will be 0. So don't need to think much about it. Acceleration is supposed to be 5. Time is supposed to be 5.
25. 5 squared.
Yeah. So tell me the final answer.
So it's 0 plus half times. Wait. Um. 62.5.
Exactly.